Okay, I took this picture at a point in time when the whiteboard was disconnecting, so hopefully we can follow along here, even though the picture is a little dark. Okay, here's a diagram of what's happening. We've got circle O with the chord BC, midpoint M of that chord, and we're extending MO so that the length from O to A is twice the radius. Okay, and we want to find the angle theta right here that maximizes the area of that triangle, the blue triangle ABC. So can we find a formula for the area of the triangle based on theta? Well, the area of the triangle, this of course is a right angle because radii passing through the midpoint of a chord are perpendicular to the chord. So AM is an altitude of that blue triangle, and the chord BC is a base. So if we call this a little b and this little b, because M is a midpoint, and H this altitude right here of triangle OBC, then the area of that triangle is 1/2 the base, which is 2b's, times the height, 2a plus h, because we call this little segment right here h. And I can cancel these out and distribute the b, so there's a formula for the area of the blue triangle. Now, can we get a and b depending on theta? Well, the cosine of theta is h over a, which implies that h is a cosine of theta. And likewise, the sine of theta is b over a, so b is a sine of theta. So I'm going to plug these values for b and h into this formula right here, and that will be a of theta. 2a, there's the b, plus b times h simplifies to this, where of course a is a constant. So to maximize that function, we'll take the derivative and set it equal to 0, where I factored out this a squared here. I just got a message that the whiteboard has been reconnected. Hopefully this video is continuous. So the derivative of 2 sine theta is 2 cosine theta. Over here we have to use the product rule. First times the derivative of the second, plus the second times the derivative of the first. These two terms right here are cosine squared minus sine squared, which leads to this double angle formula. So I replaced cosine squared minus sine squared with 2 cosine squared minus 1. When does this equal 0? Well, obviously it doesn't matter what a is, because that can be divided out. So we want to solve this quadratic equation. I can use the quadratic formula. The cosine of theta is the opposite of b plus or minus the square root of b squared minus 4 times a times c. The number under the radical is a 12, so that's 2 radical 3, so I can cancel out one of the 2's. So cosine of theta is that number. If I chose the negative square root, I would get something outside the interval for inverse cosine theta. So theta is the inverse cosine of -1 plus square root of 3 all over 2, about 68.5293 degrees. They ask for the nearest minute, so we have to multiply 5.5293 times 60 minutes, which rounds off to about 32 minutes. So 68 degrees, 32 minutes approximately. That angle maximizes the area of that triangle. There you go. Hope that helped. Oh, and well, you could apply the first or second derivative test to prove that this is generating a maximum area. We won't go into that detail in this video. There you go.